let's have a look at this thing that we call the discriminant in a little bit more detail. So as I said the other day, it's the bit under the square root sign, so b squared minus 4ac. It can tell us a lot about the roots. One of the main things it can tell us is whether we're going to have rational or irrational roots. Now if the discriminant is greater than 0, then I know we're going to have two different real roots. So if we're talking about the picture, it means it's going to cut the x-axis twice. If it's equal to 0, and here's the interesting thing, it still has two roots. It's just that they're the same. Okay? And this is the difference between roots and, say, solutions to an equation. There's only one solution to the equation, but it still has two roots. Okay? And if we were looking at the picture, it would just touch. It's one of those parabolas that touches the x-axis. Now, if it's less than 0, then it has no real roots. It actually still has two roots, but now they're two imaginary roots. We don't have to worry about that until we start looking at the extension 2 stuff. So for now, it's good enough to say, look, it's just got no real ones. And so we'll never cut the x-axis if we were looking at the picture. So in addition, if the discriminant does turn out to be a perfect square, well, that's when we know the roots are rational. Because if it's a perfect square, we can find the square root of it. So otherwise, the roots will be irrational, because we're going to have plus or minus the square root of some number that we don't know what it is exactly. So let's describe the roots of this particular quadratic, 3x squared plus 5x plus 9. So let's find the discriminant. It turns out to be negative 83. So for now, until we start talking about imaginary numbers, the best we can say here is, well, that's got no real roots. And that's all we can really say about it. 2x squared plus 6x minus 3, the discriminant is 60. So it's a positive number. So what are all the different things you can tell me about the roots of this equation? Yeah, there's two of them. Okay, yeah. What else? They're different, yeah. What else? They're irrational. Okay. So we've got two different real irrational roots. All right, well now we're going to have an equation where, depending on what the value of k is, will change the nature of the roots of the equation. So if we want this equation to have equal roots, what value or values can k have? So in order to have equal roots, the discriminant would have to be 0, because that's when we said we had two equal roots. So we basically want to solve b squared minus 4ac, in this case 6 squared minus 4k, is equal to 0. There's only one possibility for k for this one, so that'll happen when k equals 9. And in fact, that turns out to be the perfect square. Because if you think about it, it's got to be the perfect square to have one solution to the equation. So the other way I could have worked out k is I could have said, well, what's half the coefficient of x squared? Unreal roots. The condition for that? Less than 0. So now we've got an inequality to solve. b squared minus 4ac less than 0 turns out to be k is greater than 2. So whenever k is greater than 2, this equation will not have any real solutions. What about real roots? The condition for real roots? Close. Greater than or equal to. Okay. Greater than was if they were different real roots. Equal to was if they were the same. But both conditions are real. So we'd have discriminant greater than or equal to 0. And solve that particular inequality, we end up with k squared is less than or equal to minus a quarter, not minus a quarter, positive a quarter. So k is in between minus a half and a half. Now, you might be looking at this question and thinking, well, this is a rather strange question to have in the middle of talking about the discriminant. For what value of a is the line y equals ax a tangent to this circle? Well, what we can do is, if I was to say to you, what's the point of an intersection of the circle and the line, the first thing you would do would be try and solve them simultaneously. I'm not actually interested in the value of x. What I'm interested in is how many are there. Because if there's only one solution, then I know that line must be a tangent. And so I don't have to solve this equation. All I have to do is work out when the discriminant is equal to 0, because that's when we'll end up with one solution. So let's make it look like a quadratic. I'll group the x squareds together, the x and the number by itself. So we'll know it'll be a tangent when the discriminant is 0. B squared minus 4ac. We can divide everything by 100 there to make life a bit easier. I said divide everything by 100. That's better. 3a squared plus 4a is equal to 0. And so we've got two possibilities. A equals 0 or a equals minus 4 on 3. And that makes sense, I suppose, because you usually end up with, if you've got some external point, you're going to end up with two tangents going to the circle. Okay. So A10, playing around with the discriminants.